Hello everyone, today I will introduce my project. It is the automatic frequency scaling for embedded core-processor acceleration. This project is special and interesting things compared with others because it should work in hardware and not only for software development. Okay, yeah. This is my hardware NVIDIA Jetson TX1 board. It is the low power platform for maximum 15 watts. And it can be used to some popular field, for example, the automatic driving car and the robot system. However, those applications is sensitive with the power consumption. Even use the low power platform, one still need to think about how to make the energy saving. So back to my project, I will solve this open question by my method. We first use the power module function to collect the hardware running date. It includes the 10 stamp, totally power, GPU power, and the CPU power, and also will collect the 4-core CPU frequency and finally is GPU frequency. However, for the original data analysis, we just came together this line chart. It only shows the linear relationship with the whole parameters. We can't get the best frequency and the power consumption result on it. We think about use the K-means algorithm to do the unsurprising learning to our data analysis. The K-means algorithm will cluster the data to do the classification. In our data, the CPU frequency has the 4 steps, and the GPU frequency has the 13 frequency steps. So there is whole of the frequency step showing in here. We chose the 13 as the K-means algorithm parameter in the processing. That's according to the GPU frequency is the 13 steps. Right, we can look for the K-means algorithm output. There is already divided the data into the 13 classes by the totally power parameter. And due to the K-means, the algorithm requires the huge difference the filter to get the strong result. We persist the totally power parameter for the value for the 10 tenths in the calculation with the original data. Let's get this K-means is a strong output. And then we manually choose the average one. This is the number 7 class as the positive sample state set, and because we think average class is a good option for our data. And also we chose the first one and the last one class as the negative the simple data set according to there is too low and too high of the values. So right, we will send these 2 data sets to the random forest this algorithm for the machine learning to get the class file. There's one of the positive and the other one is negative data sets can do training it. And finally we will get the class file that can to help us to predict the application frequency the state. In the test stage, we just send the power monitor data to the random forest algorithm again, and it will output the 2 and the 4th for each frequency combination the state. For example, in this the result, the subtraction size means this the CPU and the GPU frequency combination. The setting is the bad, is not good, and also it show for this additional size. That means currently this CPU frequency and the GPU frequency the combination is good. We don't need to change it, so we just follow this output for one by one to change and control the hardware frequency setting is enough. So finally, we just need to combine this currently the random forest algorithm with on the power monitor function and give it the kernel control permission just to dynamic the frequency scale. That is the project all. Okay, yeah, thank you for listening. Good.